All right, welcome to the Explainer. Today we're going to break down a really powerful idea, something called self-attention. This is the concept that basically taught AI how to truly understand human language. So let's dive right in.
Before an AI can do any of the cool stuff, write an email for you, translate a language, or just understand a simple question, it has to get past this really fundamental hurdle. How does it get the meaning of words, especially when that meaning can change all the time, depending on the context?
See, the thing is, computers don't speak English. They don't get happy or sad, cat or dog. They speak math. They only get numbers. So this is job number one for literally any language application, from analyzing customer reviews to building chatbots, turning our words into their numbers.
So how exactly do we do that? Well, this journey of turning words into numbers, it's actually pretty fascinating. Let's take a look at how it's evolved.
Okay, so in the early days, you had these pretty simple methods. Things like one-hot encoding, which was basically just a switch. Is the word here or not? Then you had bag of words, which was a little better. It just counted how many times a word showed up. But you can probably see the problem, right? These methods treated every word like an island, totally isolated. They were missing the crucial part, the relationships between the words.
And then came the next step. And this wasn't just a small improvement. No, this was a massive breakthrough. This is when machines finally started to get what language is all about: meaning.
So instead of just counting words, researchers did something really clever. They took these huge digital brains, we call them neural networks, and just fed them tons and tons of text, like entire libraries. And by churning through all that data, the network learned to represent every single word as a big, fancy list of numbers. We call that list a vector. And this vector, it's like a mathematical fingerprint for the word's meaning. And what's so cool about this is that these vectors create, well, basically a map of meaning. Imagine a giant three-dimensional or even n-dimensional galaxy of words. And in this galaxy, words that mean similar things start to cluster together, like stars in a constellation. So for instance, the vector, that list of numbers for king, is going to be super close to the vector for queen. It makes sense, right? They share all these ideas like royalty and power. But then you have a word like cricketer, and its vector is going to be way, way off in a completely different neighborhood on the map, hanging out with other sports-related words. Now this was a huge deal, a massive leap forward. But there was a fatal flaw, a really big problem. The meaning of these words was completely static. It was locked in place, and that was a problem. Here's the issue. The meaning for each word was set in stone. It was static, because the vector for a word was basically just the average of all the different ways it had ever been used in the training data. It couldn't change its mind depending on the sentence it was in right now. Okay, let's look at a sentence that perfectly highlights this problem. Apple launched a new phone while I was eating an orange. For you and me, this is easy. We get it instantly. But for an AI using these static embeddings, this sentence is a total minefield. Okay, look at the word apple. It can be a company or it can be a fruit. Now, think about all the text out there. The word apple as a fruit probably shows up way more often, so that static, averaged-out embedding is going to lean heavily towards fruit. Even with clues like launched and phone sitting right next to it, the AI is probably still thinking about the kind you eat. And that's the absolute key takeaway here. The embedding is static. It can't change based on the words around it. The system desperately needed a way to make its understanding dynamic. It needed to be able to look at the whole sentence and say, oh, wait, in this context, Apple means the tech company, not the fruit. And this is where our solution comes in. An incredibly elegant, totally game-changing idea that really unlocked the next generation of AI. And it's called the self-attention mechanism. The best way to think about self-attention is like a context machine. It takes those basic, kind of dumb static embeddings as the input, then it does its magic. It looks at the whole sentence, figures out all the relationships between the words, and what comes out the other end are brand new, smart embeddings that are custom built for that specific sentence. So here's how it works step by step. First, you feed it the old-school static embeddings for every word. Then, the mechanism looks at all the words at the same time and figures out who's important to whom. Finally, it spits out a brand new context-aware embedding for every single word. It looks at Apple and sees launched, and it cranks up a technology part of its meaning. It sees eating and orange and goes, okay, those two are related, but they're not as important to this apple. It's literally rewriting the meaning of every word on the fly based on its neighbors.
So you can see, this is way more than just a clever technical trick. This one single mechanism, it's the foundation, the bedrock of pretty much all the advanced AI you use every single day.
And I am not exaggerating when I say this, understanding self-attention is the key to understanding modern AI. If you get this one concept, you're on your way to understanding how all these incredible new models actually work.
The impact is just staggering. Here's how it all connects. Self-attention is the core engine inside something called the transformer architecture. Transformers are what make large language models, LLMs, possible. And LLMs are the technology behind almost all of the generative AI tools that are completely changing the world. It all comes back to this one idea. So when you boil it all down, self-attention is what allows an AI to stop seeing language as just a list of words in a row. Instead, it sees a dynamic, living, interconnected web of meaning. It's really the difference between seeing individual trees and finally understanding the entire forest. So, it's this amazing ability to weigh relationships and rewrite meaning on the fly that gives AI the power to finally, truly read between the lines. But that brings up a really interesting question, doesn't it? What are the actual numbers, the calculations that make this whole attention thing work? Well, that's what we're going to dive into in our next explainer. Thanks for joining us.